Okay, this video is going to be U substitution with trigonometry. It's more practice with the U substitution, and I'm going to show you how trigonometry is a really good place to use the U substitution. This is a very short video, so we just have a few examples. For the first example, as I've been showing you, I like to, let's change that color, I like to rewrite my problem so that the bulk of it is first. That puts the 3 in the back here with the dx. One of the things that you have to do for U substitution is figure out what's going to be the U. So in this problem, I can either have sine be my U, or I can have the 3x minus 1 be my U. Let's try what happens if sine is the U. If sine's my U, then my du, remember du is the derivative directly of that. The derivative of sine 3x minus 1 would be cosine 3x minus 1 times 3. And then there'd be a dx. Well, that's no good for us because we don't have a cosine up here in the problem. So I'm going to erase that. I know it doesn't work. So let's switch this and try letting the u be the 3x minus 1 part. If u is 3x minus 1, then the derivative of 3x minus 1 is 3 dx. And you can see that that's right there. Now, the way this would work for actually plugging in the u is you would directly substitute. So 3x minus 1 would be changed to u, and 3 dx would be changed to du. So now I have the u and the du as the same variable. And so if I look at this to integrate it, I see I have sine u du. So I'm integrating sine. Sine integrates to negative cosine. That would be negative cosine of u plus c. Then I would just go back and say negative cosine. My u was 3x minus 1. I'm going to plug that back in with my plus c, and then that's going to be my answer. Okay? A lot of times you can do this by recognizing the pattern. You can say, oh, I know what my u is going to be. I know what my du is going to be. I don't have to go through the process of actually substituting it. But a lot of times, if you do some practice with the substitution, it makes the recognition easier. Alright, so let's try this one. If I rewrite this, 3x squared plus 1 x dx, well, before I even do my u, I know that u can't be cosine, because the derivative of u, the derivative of cosine would be sine, and there's not a sine in my problem. So I'm immediately going to jump to the 3x squared plus 1 and see if this works. The derivative of 3x squared plus 1 would be 6x dx. Okay, and so I would come up here, and I like to go ahead and fix this. So I'd make this 6x dx, and I balance it with a 1/6. So now I can make an exact substitution. So this would be cosine of u du, and now I can see, oh, I'm just integrating cosine. So 1/6 cosine integrates to become sine u plus c. Now let's place the x's back into the problem. We used u for the substitution, so my u is 3x squared plus 1 plus c. So the u substitution helps me figure out the solution, but then in the end we take the u back out. Alright, let's try another one. Rewrite it. Secant squared x dx. One thing you might even want to do is erase the squared here and put this all together squared. And that's just, personal preference. Okay, so if I'm trying to look for a u, the derivative of secant would be secant tangent. There's not a tangent in my problem, so I know I'm not going to use secant for the u. So let's try using x squared instead. If x squared is my u, the derivative of x squared is 2x dx. So I would need a 2 in here, and I would balance it with a 1/2. So this would be 1/2 the integral of secant u squared du. Secant squared is the derivative of tangent. So this would be 1/2 tangent u plus c, which would become 1/2 tangent x squared plus c, just replacing the u with x squared. Okay, now that we've done 3 of these, you're probably starting to see the pattern. What am I going to do for this problem? Well, first of all, it seems to be missing a dx. I'm going to put secant squared first because it's the biggest power, and then I'm going to write tangent x over 3 dx. Now this time, if I think of this in terms of secant, okay, so let's even write this as secant x over 3 parentheses squared tangent x over 3 dx. If I think of it in terms of that, then you can kind of see, well, the derivative of secant is secant tangent. And so it's possible that this is all here, so let's check it. If my u were secant x over 3, then my du would be secant x over 3 tangent x over 3 dx. Oh, sorry, 1/3 dx, because the derivative of x over 3 is 1/3. So if you look at how this problem is set up, what if we were to rewrite it in my open space up here? Let's rewrite this all together. Let's write it as secant x over 3 times secant x over 3, because that's what secant squared would be, times tangent x over 3 dx. Now, when you look at my u that I've put down here, you can see that this could be my u, and this part would all be my du, and it's just missing a little part. So now that we can see how this would fit, what I'm going to do is say I'm missing that 1/3. So if I put a 1/3 in here to be part of my dx, I would balance it with a 3 on the outside. So now this is 3. Secant x over 3 is now u. We're making a direct substitution because u equals this. Secant x over 3 tangent x over 3 1/3 dx all is equal to du. Now look at what we're integrating, u du. Well, how does that integrate? U becomes u squared over 2. We already had a 3 out there. We do plus c. And then now all we have to do is replace my u with what u equals. And let's see if I have a way of writing this with you being able to see it. So I'm going to write this as 3/2, just putting the 3 and the 2 together. The u is secant x over 3, and it's squared right there, plus c. So this integrated to become 3/2 secant x over 3 squared plus c. Alright, I will have an extra practice worksheet for you that does some more practice with trigonometry and a few problems that will be non-trigonometry that you can practice with the u substitution.